Hello, today I want to talk about CSS, but CSS that created by JavaScript, and all this called Houdini project. And particularly I will be speaking about Paint API. So before we start, some few words about me. I'm co-organizing Angular Wrocław here. We have meetups monthly, we bring a lot of great speakers here, and also I love CSS because CSS is awesome and you can create crazy things without any line of JavaScript, just with CSS. I'm also participating as a mentor at NG Girls events internally inside company, and I have few open source projects that I'm maintaining and trying to contribute when I have free time. You can follow me on Twitter and visit my personal blog. And another few words about Angular Wrocław. You can follow us on Twitter and check out our page on meetup.com. So everybody is welcome. We are welcome first-time speakers. If you want to prepare any talk, we will support you with that, with advice, with choosing topics. So feel free to contact us and speak at our meetup. So what is Houdini project? When people hear this name, they usually think about this man. This serious magician, famous illusionist. And Houdini project for CSS related to magic because it allows you to extend CSS capabilities and gives you access to CSS engine internals. So CSS Paint API is just one API of Houdini project that gives you ability to draw canvas images on different properties that accepts images. We will see it later on. So what is the problem? Why we need this Houdini project? On one side we have us developers. So we want to use some feature only after browser implemented it. On the other side we have browsers that want to implement some feature only if some of developers, some resources uses these features. They are not interested to implement immediately features that are not used today. And with all this we have circle dependency and everybody just waiting for something, and this waiting might be as long as few years, for example. We have such proposals like position sticky that haven't implemented in all browsers till now. We only have it in Firefox and Chrome. We have CSS grids that have great support right now, but haven't implemented subgrids features. And it's really problematic to fallback such rich CSS features now. You can only fallback on old one, like floats, for example, with grid, or flexboxes. And why it's so hard? Because we have this CSS rendering pipeline. We have parser that builds our CSS object model, then we apply cascade rules, and there are three stages of creating image for a user. First of all, we have layout stage. We define where each particular element will be placed on the screen. Then we paint in each element. And after that, we apply a layout on each other with composite stage. Why it's so hard to polyfill it with JavaScript? The biggest problem is that JavaScript polyfills for CSS are too big, and that is why they're slow. And they applied too late. They applied after whole rendering pipeline already done, and then we changing something in CSS and triggering the whole pipeline again. So it reduces the responsibility of our applications. And they're incorrect because it's really hard to behave like CSS engine, to apply rules according to cascade, to invalidate rules on different media queries, on screen sizes changes, and so on. That is why with JavaScript you can polyfill some features, but it's hard and non-performant. On the other side, we have compile time polyfills with post-CSS. Post-CSS is like Babel but for CSS. It allows you to use latest syntax features right now and transpile it down to CSS that be used with browsers like IE, like Edge, Chrome, with all prefixes. This project, the only thing that it does, it builds abstract syntax tree of CSS and applies plugins. The most famous one is after prefixer. It applies all prefixes according to your browser support config. It's called browser's list. And right now Babel also uses the same configuration, browser's list, to apply Babel and a plugin. So it polyfills JavaScript features according to browsers you're gonna to support. So we have all this rendering pipeline, and Houdini provides an API for almost all of these stages. So we have parsing API, we have type API, which is typed CSS properties available from browser. We have CSS Paint APIs that applies on Paint stage. We have layout APIs that allows you to create in the future some custom layout properties for display. And we have animation worklet. And three of these APIs, layout, paint, and animation worklet, they are gathered together with worklet API. So it's high-level APIs that based on more low-level one called worklets. So what is worklet? Worklet is something really similar to web worker, but it's worklet, and it means that you're using separate JavaScript context. It's isolated from main context using for your bundle, and it allows you by design to execute these worklets on separate browser thread. So you can do something in parallel with your main application code. If we speaking about Paint API, this means that you can draw some huge amount of canvas, doing animations, and it won't affect your application code. It won't freeze the UI. What is CSS Paint API? So CSS Paint is a worklet, so it extends this specification and executes in separate CSS Paint worklet context that hasn't almost no asynchronous functionality inside, like set timeouts, like asynchronous imports. You can't use it here. Also, CSS Paint worklet is stateless, so by design, browsers might terminate your instance of worklet and create new one and swapping them over the time to achieve better performance. That is why you want to keep any state inside worklet. You need to keep it outside with CSS properties or in JavaScript and so on. So CSS Paint API allows you to create images to use with background image, borders image, or any custom properties that accepts image type. In this case, I mean CSS image type. So how to use it? In CSS we have special function called paint, and inside this function you need to pass the name of your paint worklet that you created. What about browser support right now? So first it was shipped in Chrome 65 this March. Also it migrated to all Blink-based browsers like Opera, and each are interesting to implement it, but first of all they need to implement worklets and all basic environment to create Paint API. And just recently, a week ago, Safari in technical preview enabled CSS Paint API for Safari on Mac. So they are already working on it, and hopefully it will come soon. Also, the Paint API specification on which we see, or if we compare to all Houdini APIs, is more stable because it's now on stage of release recommendation. The API is stabilized, they need to just check some corner cases and the specification will be done. And as any other CSS property, it is easy to fall back. If browser don't have support for CSS Paint API, it will just ignore the rule. So if browser don't know nothing about paint function, just ignore it. So we can provide fallback rule like static image or solid color, and browser will use it instead of Paint API. Also, we have a polyfill. It was created by Jason Miller, creator of Preact. And this man really knows how to do performance DOM operations. This polyfill is in JavaScript, and actually it creates element in DOM behind your elements that you want to apply CSS Paint, and create canvas element and draw on real canvas element. So it's not so performant, but it allows you to enable and use CSS Paint right now in any browsers that haven't support right now. How to create a custom Paint API worklet? So first of all, we need to define a painter class in separate file. This limitation to create worklets in separate files are security restrictions, because you have no access to global context inside your web app or web page, and it's completely isolated. You can omit this security restriction with some workarounds, like create some special script tag with inline code and then transform it to base 64 and then load this base 64. But anyway, you will not access document, window and other global variables. Then we need to call special function and register our Paint worklet, and browser will know that it has Paint worklet with particular name and implementation. And after that, we need to load our worklet. We need to call CSS Paint worklet load module and provide the path to our Paint API file. How it looks like in code. So, Paint worklet class is just usual JavaScript class, and it needs to implement one method, paint. And this method accepts context, which is 2D canvas context with some limitations. It's not equal to the canvas we have on global scope. We have geometry object, which gives us the particular size of our element right now, like width and height. And optionally, we can provide properties and arguments. We will speak about them a little bit later. And inside the same file, we need to call register paint function. It's special function that available in Paint worklet context. And first argument is the name of our worklet that will be used in CSS then. The second argument is our worklet class. It could be also inline class without any name, anonymous. And in this case, we provide a named class name as a reference. And last step, on your main bundle or even inline JavaScript, you need to load your worklet. So first of all, we want to break anything for our application, and we checking if CSS Paint worklet available in CSS object globally. So we checking if Paint worklet in CSS, and then we calling CSS Paint worklet add module, and we providing path to our files that we created with worklet. Also, this allows you to check the availability of this feature and fallback it somehow. For example, load polyfill or load another style sheet that uses solid colors and images instead painters. How it looks like on practice, because words are nothing but show me the code. And of course, I want all of you to try it at home, to create some Paint worklet experience on your own and share on Twitter or Facebook. How looks like Hello World Paint worklet? So we have class, in this case is circles painter, and we have paint method that accepts context and geometry. Then we accessing widths and heights of element from geometry object and draw some circles. Later on, we register our paint called circles and passing the name of our class. So in this example, I'm going through double loop and draw 4 circles with different colors on the element. Then, in CSS, I'm calling that I want to use circle paint. I'm calling paint function and passing the name of painter that we registered, circles. And for fallback, I providing solid black color. So if browser have no support, it just draws the black color. So how it looks like? We have this element with 4 circles. And when I change the size of the element itself, it calls the render method for me. I added just console log. And you see, Chrome provides the context of this console log. It's paint.js, it's separate module with our painter. And the interesting thing is that it's not working on just viewport size changes, but on element size changes itself. So if we try to change the size of this element, it will render for us, like, let's say, it won't. Why? It's okay. I use here padding hack to preserve the aspect ratio of the element. So yeah, and every time we change the size of element itself, not the viewport, it calls for us this paint renderer. Let's go next. We can subscribe to some properties, and it could be custom properties, CSS variables, or just usual CSS properties like margins, paddings, whatever. So to do so, we need to define static method, input properties, and it should return the list of strings with name of properties we want to subscribe to. This means that on any of these properties we are interested in, if any of them changes, Paint API will call render functions for us. So in Paint method, we have access to these properties, and properties is the special read-only map of CSS properties that we can parse and provide some defaults if nothing specified. How it looks like in CSS. So in CSS we define these custom properties like circles count, offset, and opacity. And if any of them will be changed, Paint renderer will be called for us. So here I have sliders and simple script that updates properties on slider changes. And you see, when I change any of these properties, the image generated by Painter will be changed for me. Also, we can not subscribe to some properties, but pass some arguments inside function. And it semantically more similar to what we do in CSS. For example, with linear gradient function, you pass in a bunch of arguments with colors and color stops values, and it works like passing arguments to JavaScript function. So to do so, we define another static method called input arguments that should return a list of arguments we want. But this time we provide the list of types we want to support as arguments. CSS engine always parsing our CSS, and CSS is just strings. After CSS engine parses them, it defines which type of each value has. So, for example, we have width 100%. CSS engine parses this 100% string and recognize that this is percentage type and value is 100. The same doing with degrees, pixels, and all CSS units we have. And CSS Houdini project provides us another API called properties and values that gives us ability to work with CSS types in our scripts own. Also, in Chrome, they already ship type ATM, which allows you to work with CSS types. So you, for example, when you animate something, like size of element from 0 to 100 pixels, you want to work with strings, but you can work with actual CSS units. It's objects that have value and the type. And here we have special syntax for define CSS types. It's this like tag brackets and types like number, percentage, pixels, a bunch of them, but not all of them already supported, because it's really hard to standardize all these things. But browsers using these types internally for ages. Then we can access these arguments, and arguments similar to JavaScript arguments object for functions. It's a list like structure that stores all these arguments. So we can parse them and provide defaults as well. And in CSS now, instead of specifying custom properties, we pass in values inside our paint function. And again, if any of arguments will change, CSS Paint will call render for us. And now, now I have this function, and if I change any of argument, it will re-render the layout for me. And last one, static properties that we have, context options. And for options right now we have only one option, alpha. What does it mean? If you don't care about layers below your element, you don't care about opacity of your layout, you can just specify alpha to false, and you got some performance bonus from that. The browser will not calculate some opacity and layers composition. So just another performance tweak. This was just basic overview of the API itself, but I want to show something more practical that could be used somewhere. And some of demos I will show, they still require some flagging Chrome experimental web platform features. Because in some demos I using also properties and values API and type-to-m, so whole Houdini APIs work in combination with each other. You can combine them to achieve awesome results. So first of all, we can make some generative backgrounds. And the simplest example is like you can generate different images related to the size of the element itself. So in this case, I'm checking the width property, and according to the value of width, I'm changing the colors of circles. And again, it's work not on viewport size changes, but on element changes, like max width. It's 2. So at some point it should change the color. Not sure at which one. Let's try. Okay, it should be bigger. And yeah. It was the first use case. And it allows you not to just change the colors of something that you can actually do with media queries, but you can provide more or less details for image, like doing some progressive logo. The real use case, for example, you have logo with many details on the white screens. But on smaller one, users don't care about such details, so you can cut them off and simplify your logo for mobile devices. Also, we can generate some patterns. In this example, I generated some patterns with simple figures like circles, triangles. I can switch the palette that I also pass in like a list of arguments here. And again, on element changes, it regenerates this pattern background. The last thing, I'm using it on my blog. It's material kind of background image generated with Paint API. And I did small research. So I have the same images for all browsers, like JPG one, and for browsers that supports CSS Paint, I have generated one. So I have both, and I compare the size of them. So my CSS Paint worklet minified is just 800 bytes. And the JPG compressed image that cropped for mobile devices, I use in media queries to provide different backgrounds, is 2 kilobytes. So it's the smallest image, but the size is like 3 times greater than CSS Paint worklet. Of course, for CSS worklet, I only measured Painter script only, and I have some bytes to apply property, like background image, paint, material background, and few lines of JavaScript to load worklet itself. So maybe it's like 100 bytes, let it be like this. But still, it's smaller than the smallest JPG image. We can't compare a size of JavaScript and image directly, but for such small numbers, I think JavaScript parsing won't be a big overhead. So at least we saved users' network with CSS Paint. And the thing that I don't need few Paint worklets to provide different images for different screen sizes. It's responsive by design. I have the size of the element and I can adjust the image on real time. Also, we can save the DOM. We can reduce the number of DOM nodes with CSS Paint API. If I'm kind of fan of material design, so they have ripple effect when you click on buttons. And originally on JavaScript libraries with material design, they created some span element inside button to animate it. But with CSS Paint API, you can just generate this ripple effect without any additional DOM nodes. So imagine that you have web app and on one screen you have 10 buttons. 10 buttons means 10 additional span elements. And with CSS Paint API, you can reduce this size. It's also a really nice feature. Next one, I created simple star rating. So it's just 5 stars and it's colored regarding the value provided. This is actually the helper function to draw stars. I can choose the radius and number of corners of each star. Because it's really easy to do with canvas. And here is it. So it's nice stars and we can provide value. When we change this value custom property, it renders this rating for us. And as I said, it was easy to implement whatever star I want, like 6, 8 corners. And in general, this one worklet is less than 550 lines of code in worklet itself. Then I go deeper. I imported some library that allows you to generate QR code and render it on canvas. And I created Painter to generate canvas QR code. So we have element, and as background it has QR code. We can provide string link we need to encode, and few parameters of quality QR code and its mode. And you can check it, it's working, and refreshes on changes of the link, so it renders automatically. And now I'm working, I still haven't finished it, I compiled the Rust library to WebAssembly, and I want to use WebAssembly module to generate QR code that should give me some performance boost. I will measure it afterwards, so it's also cool, and you can do something useful. I created some generated circle chart. I call this chart circle because it combines two kinds of charts, like donut chart and pie chart. And again, it was so easy to implement it with canvas. And it looks like this. We have inner radius value that allows you to make donut, or if this 0, it will be pie chart, outer radius, and we have the value of the chart itself. We can change the colors, like this one. And again, we changing just CSS properties and it renders chart for us. Then I created bar charts, because you can create rectangles in canvas just with one line. And they're looking like this one. I can change the side, like left, right. I can change the gap between bars and so on. Then I applied some techniques that actually are presented in CSS specification. It's JavaScript inside CSS. Not CSS inside JavaScript, but other. So I have a custom property, and I passed a list like of JSON objects with values and colors to use with bars. And then I animated them. So yeah, again, the same bar chart, but on hover I changed the mapping for data. And I have it in CSS. It's just list of objects with value and color. And again, I have the same side changing, but passing values like from CSS. And yeah, I want to show how to animate things. Usually to animate custom property CSS variable, you need to update them on request animation frame. Why so? Because CSS variables for browser just strings, and browser have no idea how to interpolate one string into another string and animate it. But browser has built-in functionality to interpolate CSS units like pixels, colors, and so on. But how to give browser the idea what type we want to use? And for that we can use custom properties and values API. It allows you to register your custom property and apply the type for it. So we call it special function called register property and providing options object. Name of our custom property, syntax, which means the CSS type, if it should inherit, and its initial value. So let's look on it. This example I have again this JS and CSS, but now on hover I generate a new dataset and animating this property with request animation frame. So it's like old variant. But I can register them as types. Also we can create some stateful animations with some particles, like this download progress bar. And you can see that in this example I'm trying to keep the state of particles inside Paint worklet, and it's kind of blinking because it shouldn't be kept there. I need to move it to CSS properties or in main thread JavaScript. Also we can create some cool stuff like this is a grid of images with unusual borders, and we can configure custom properties to have gap and generate different kind of borders. And it's, I can say that unreachable with JavaScript, but it will be hard to make the same result without CSS Paint API. So for these custom properties, they have proposal for second level of API to define these custom properties inside CSS instead JavaScript. And the syntax will look like this. We have add property, then we pass in the name of our custom property and the same options as we pass in JavaScript, like syntax, initial value, and inherits. And what I did, I created post-CSS plugin to transform CSS declarations to JavaScript one. So you can check it out, and just yesterday Houdini committee agreed that this will be done in next level of API, so syntax won't to change, and you can try this new feature right now with post-CSS plugin. Where you can find some info about Houdini, demos, and so on. This guy, John Leon, he created a GitHub repository called Awesome Houdini, and here he gathering all articles, all demos, all talks about Houdini, its APIs, so all resources that could be found in the network, and you can check it out on GitHub. So that's all what I have. Remember to try to create some Paint API worklet at home, and thank you.